Hello. Welcome to Denver. It's a little cold here right now. But that's not what we're talking about today. We're talking about standards for broadcast and how they are affecting how you do broadcasting. So, we're going to talk about the NRSC, National Radio Standards Committee. And that is a partnership between the National Association of Broadcasters and the Consumer Electronics Association. So the two of them come together to do this standards for broadcast and broadcast receivers. So that way, it really is a way for broadcasters to know how the receivers are going to handle their audio, and for receivers, manufacturers to know how broadcasters are going to be transmitting audio. So kind of works out in both ways. But their purpose, according to their website, is to explore technology, make recommendations for technical standards for radio broadcasting and the reception of radio broadcast signals. If we look on their website, we can see that they have 4 standards and 8 guidelines, at least as of right now, that pertain to broadcasting, both AM and FM, RDBS or RDS, IBOC or HD radio, metadata, emergency alert systems, and more. And they started putting together these standards in the 1980s, and some of these standards have actually been incorporated into the FCC rules and regulations, and, well, now they're rules and regulations. But NRSC 1 was adopted in 1987 and deals with pre-emphasis on AM stations and de-emphasis on AM radio receivers. If you're ever listening to AM radio, you'll notice that it just doesn't sound very crisp. It has that dull sound to it. Well, that's intentional, and it's created so that way it rejects adjacent stations to the one you're listening to, and overall it helps improve reception to the AM station. The reason for this standard is to allow broadcasters to have a reasonable expectation of how the audio will sound on receivers, and for receiver manufacturers to know how an AM broadcast will sound. The standard was updated as recently as 2018, so this is still something that's important. The main thing about this standard is what's called the pre-emphasis curve, and it's the way that they adjust the audio, the high-frequency audio on the AM signal. So for AM broadcasters, they will boost it by 10 dB, and on the AM radio receivers, they will cut it by 10 dB. So again, it's just to help with reception for these stations. NRSC 2 came out about a year later and dealt with what's called occupied bandwidth. So that's the RF signal and how much bandwidth it occupies on the radio spectrum. Let's take a look at the mask that the NRSC has created. We have a solid line, and that's called our limit line. And then the RF emissions are not allowed to go past that line. There's a whole table about how far away from the carrier the RF must be down. And I mentioned carrier, and the carrier is basically the center of that AM signal. NRSC 3 deals more with the receivers, and it complements NRSC 1. It talks about how the receiver is essentially built, how the RF is captured and turned into audio, and it created this certification program for radio receivers. So that's another plus there for radio receivers. I had to get down and get out of the wind because it's getting a little chilly. Okay, NRSC 4 talks about the Radio Broadcast Data System Standard. It describes the RDS system and creates the standard that is basically compatible with the European standard. The only difference is that there's extra parts for U.S. broadcasters, things like a program types list, some things that are different for U.S., an emergency alert system program type, some paging information, and the possibility of using RBDS for AM stations. I have not seen that in the wild, but the standard is there. There's a part that allows for a receiver to automatically switch to a stronger signal. Not many stations use that here in the U.S., and it's think of it this way. You have a bunch of stations down a highway or a freeway, and this gives you that ability to set these frequencies in its RDS, so as you are traveling, your radio will automatically tune to the next station based on signal strength. And really, overall, this standard is meant to make the radio much more user-friendly by adding metadata, title, and artist. I mean, how many times have I been wondering, gosh, what song is this? And I look over at the radio display and it tells me who the title and artist is. RDS data is transmitted in the 57 kilohertz portion of the FM signal, in case you wanted to know, at a bit rate of 1,187.5 bits per second. NRSC5 brings us into the digital age. It deals with IBOC, also called HD radio, which, by the way, does not mean high definition and does not mean hybrid digital. It means nothing. It is a marketing term. Anyways, that's for another video. This standard was released in 2005. Talks about how analog audio would blend to the digital audio in order to provide a transition from analog broadcasting to digital broadcasting. We'll talk about HD radio more in another video, and the whole thing about that. I mean, there are broadcast engineers who love it, and there are broadcast engineers who hate it. So I will take a neutral stance because I have been on both sides of it. So anyways, that's it for talking about standards for broadcasting. This kind of sets a lot of the basics of what we're going to be talking about and in the future, and why we do certain things in certain ways. So thank you for watching this series of Broadcast Basics videos, and until next time, stay safe, stay healthy, stay warm, and keep learning.